Number 5. What's the probability of drawing a heart or a club from a standard deck of cards? Okay, so standard deck of cards. A lot of people don't play cards anymore, so you don't know what's in a deck of cards. How many suits are in a card? A deck. 4 suits. Okay. Those 4 suits are hearts, diamonds, clubs, and spades. Hearts and diamonds are red cards. Clubs and spades are black cards. Okay. In the hearts, you have the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. Right? That is the same for each set. You got those cards. So that's how many cards per suit? 13. 13 times 4. Okay. Jokers are not part of a standard deck of cards. Okay. So not everybody plays cards. Not everybody grew up playing cards. So knowing what's in a deck of cards is considered common knowledge, even though current generations are not card players. But hopefully it's kind of swinging back to that. A lot of folks I know do that. All right, so probability of drawing a heart or a club from a standard deck of cards. Okay, so how many hearts are there? How many clubs are there? 13. So that's 26 possible cards out of 52 to be 1/2. So that's it. Just drawing one card out of the deck. Probability of it being a heart or a club. All right. Number 6, 8 books on a lettered A through H on a shelf. Scott randomly chooses 2 books. What's the probability that he chose books A and B? Okay. Picking 2 out of a set. How many ways are there to pick 2 books from a set of 8? 8 combination 2. Doesn't matter if we pick book B or book A first. Order doesn't matter there. So it's a combination to find out how many ways there are to pick 2 books out of a set of 8. Hang on just a second, guys. Let me help her out real quick, and then we'll get to that. So y'all be finding the combination. All right, back at it. How many ways are there to do a combination of 2 books from 8? 28 ways. And if we're picking books A and B, 1 out of that. Okay. So 1 picking A and B. When we pick 2, there's only one. That's only one combination out of the 28 that are possible. Okay, right. So combinations, that's coming back from what we did last week. So on the calculator, just to remind you, if you weren't here or if you just forgot, hit math and go over to probability. If you got one of the black and white ones, it's a PRB on the menu. So you're hitting the math button on the left, going over to probability, and we're doing the combination of 8 items 2 at a time. There's 28 ways of doing that. Okay, so that's still in play for what we're doing currently. All right, let's look at complements of an event. Not compliment like I like your shirt, but complement as in complement from geometry. Remember doing the complement of a angle was what added to that gives you 90. Well, the complement of probability is the complement of an event is the probability that the event is not happening. Okay. Complement is when the probability of that event not happening. Since the sum of the probabilities in the sample space should be what? How much should all the probabilities of something? Let's take our rolling die situation with the sums. There are 36 things in there. Probability of getting a sum would be what? Just getting a sum would be 36 out of 36, which is 1, right? Probabilities of events should add up to be 1, okay? And so one of the easiest ways to find the probability of an event not happening is, and the notation is they use this little squiggle mark. Sometimes you might hear it called a tilde, but it's just a little one squiggle mark in front of the event. So probability of the event not happening is 1 minus the probability that the event did happen. Sometimes easier to figure out that way. You can do it both ways, but sometimes it's much easier and quicker just to find the probability that the event happened and then subtract that from 1. And that's what we're going to kind of employ here. Number 7, straightforward. It says probability that it will snow tomorrow is 7 out of 20. What's the probability that it will not snow? So that's a 35% chance of snow if you do the math. Tomorrow, I don't think that's going to be today's weather, but take the probability that it will not snow is 1 minus 7 over 20, which would be, 13 over 20. The probability of tilde snow. That'd be the probability of it not snowing. Number 8, a month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? I'll say so. Probability of not A. Well, what's the probability of the months that have A?
1 over 12. April.
It's April and August, right? So that's 2 out of 12. So that'd be 1 minus 2 out of 12, which would be 10 out of 12, which is 5 over 6. And you can reduce at whatever point you want to there. I'm not going to, as long as the final answer is reduced. Don't forget to do that. Okay. All right. And then number 9 says the spinner on the left. So you got the spinner there. It's got the numbers 1 through 16 on it. We spin that and find the probability that it lands on a number that is not prime. So let's mark the prime numbers: 2, 3, 5, 7, 11, 13. 1, 2, 3, 4, 5, 6. 6 prime numbers, right? So 1 minus 6 over 16 should be 10 over 16, right? Five over 8. My math right there. All right. 10. 2 dice are rolled. What's the probability of getting doubles? Okay, it's rolling 2 dice. We're not summing them now. We're just looking at the results. What's the probability of getting of not getting doubles? So how many doubles are there? 1, 1, 2, 2, 3, 3. There's 6 doubles, right, that you could get. So that'd be 1 minus 6 out of 36, which would be 30 out of 36. Reduces to 5 out of 6. So complement of an event, most of the time, a lot of times, is easier to find by just subtracting the probability of the event happening from 1. Makes it much easier a lot of times, okay? All right, let's talk about compound events. Most of the time when we're dealing with probability, if we're dealing with probability in a real-world situation, It's not usually just one simple event. Most of the time, it's a compound event. There are things called independent events and dependent events. Independent events, when the outcome of one event does not affect the outcome of the other event. Okay? The way you find that probability is you take probability of event A happening times probability of event B happening. You just straight multiply. So that would be an example of that would be if I flip a coin for one event and then draw a number from a hat for another event. Does what the coin lands on affect what comes out of the hat? Absolutely not. Those are independent events. So when you find the probability of maybe landing on heads and drawing a number 2, you're going to multiply those probabilities together. Just straight multiply them together. So independent events, you just multiply the probability of each event happening independently. Right? A key word to this is with replacement. So, for example, if we're talking about drawing cards, if you're drawing from a deck of cards and you want to know what's the probability of drawing a king and a queen with replacement, those are independent, because once I draw the first card, I put it back in the deck, and it's still a 52 card deck. So the with replacement tells you that's the independent event. Okay, if they're dealing with like one deck of cards. Okay, so with replacement's a key word to know that it's independent. Dependent events, you take the probability of event A happening times the probability of event B after A occurred. Keyword to dependent events would be without replacement. Deck of cards example is a good one for that. If you're drawing from a deck of cards and I want to know what's the probability of drawing a king and a queen, and I draw a king the first time, well, that's 4 out of 52, right? And then I don't put it back, and then the probability of drawing a queen would be 4 out of 51. Okay, so it reduces the number of possible things there. So without replacement is a key word for knowing that it's a dependent event. What happens with the first event affects what happens with the second event. Okay, so independent, dependent events. All right, so let's look at some independent events. A die is rolled 3 times, just one. What's the probability of getting ones on each roll? So when I roll that die the first time, does it affect what's going to happen to it the second time when I pick it back up and roll it? No, absolutely not. That's an independent event. So what's the probability of rolling a 1 the first time? What's the probability of rolling a 1 the second time? 1 over 6. Third time? Multiply all those together. And 6 to the third power, 216, right? The probability of rolling 3 1s in a row with one rolling die is 1 out of 216. Number 12 there says a coin is tossed, then a day of the week is selected. Is that independent or dependent? Tossing the coin changes what days I can pick.
Oh, I meant independent.
It's independent because the coin toss does not affect what days of the week exist. And then, so what's the probability of getting the tails, then a day starting with the letter T? So probability of flipping a coin and getting tails. 1/2. Probability of getting a day of the week that starts with T. 2 over 7. Okay. Multiply those together. 1 over 7. All right. A bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. A crayon is selected replaced, and then another is selected. So it tells us in the instructions that it's replaced. So we know all of these events are what? Independent, because it was replaced. All right. So probability of picking a purple, then a yellow. So what's probability of picking a purple? How many total are there? 32. And the probability of getting a yellow? 6 out of 30. Work that out. So 21, 256. And you're more than welcome to go 14 over 32 times 6 over 32. And then hit math and enter. 21 over 256. Number 14, probability of green, then red.
4 over 32.
So it'd be 1 over 32. Two purples. So purple's 14 over 32. 14 over 32, because we put it back. Should be how much? 49 over 256. Two yellows, a little easier problem there. 6 over 32. 6 over 32. 16. 9 over 256. Nothing we're doing is just extremely strenuous math here. It's just, knowing how independent, dependent events work, okay? All right, so the next little set is taking this same situation. So that same bag containing the same crayons, and let's do it without replacement, okay? Without replacement. Same situation, bag containing 8 red crayons, 14 purples, 6 yellows, and 4 greens, but we're not going to put it back when we draw it out, okay? So the number 17 there says probability of yellow then red. So what's probability of getting a yellow on the first draw? 6 out of 32. We don't put it back, so how many are there in the bag now? 31. And then reds are 8. So 6, and let's see, that's going to be 4. No, that'll go into 6 over how much? 3 over 62. 18, purple, then a green. Seven over 124. 4 times 31, 4, and 120, yeah, 124. That doesn't produce. Not too bad. 19, 2 reds. Almost. 7 over 31, because we already took one of the reds out, right?
What if you don't get a red?
When you're doing theoretical probability, is you're assuming the first event happens, that you are successful on the first event. If it were a experimental thing, then we're just drawing stuff out and recording it, and really you're not looking for. This is what we expect to happen. All right, so 1/4, and then be 7 over 124 again. Probability 2 greens. Same idea. 4 out of 32, 3 out of 31. 1/8. So it'd be 3 out of 248. So with replacement is independent. Without replacement is dependent. Okay, so make sure you pay attention to the problem. 21 says a card is drawn from a standard deck, not replaced, and another is drawn. What's the probability of choosing a heart, then a spade? 13 over 52 times over 51, yeah. 13 over 204. Jack has 4 Snicker bars and 8 Mars bars. He randomly chose a piece of candy, ate it, then chose another. What is the probability both candy bars were Snickers? 4 over 12. 3 over 11 because he ate that. So it doesn't say the word without replacement, but when he ate it, he ain't getting that back. Okay. So 1 out of 11. All right. So theoretical probability, simple events, complements of events, independent events, and dependent events. Let's see. I'm going to do conditional today. Let's just do this. We'll do conditional tomorrow. Yes, if you got this handout, the one from Tuesday, Tuesday, weekend, get that turned in today. If you got it, you don't have it.